So once again, ladies and gentlemen, welcome and thanks for joining this session. Try to understand what is the agenda for today's session. Okay. So we are going to discuss security groups in cloud, which is one of the safety feature in the cloud. And if you have a little bit of firewall background, or if you are from security, if you have a security background, then you must be knowing the few concepts which we are going to discuss, like stateful versus stateless, right? Which is really going to be important when we discuss security groups and then ACLs. So these are the two things which are kind of you can say your security mechanism to safeguard your virtual machines, which you are going to spin in cloud, right? So we will be discussing quite detail about these things, means security groups and access control list to begin with. Then we have learned a lot of concepts like virtual private cloud. We call that VPC in AWS and virtual networks in Azure, right? Then we know now what internet gateway is and how do we use that. Then security groups and ACLs, you will be knowing this when we complete the first two items. Then we are after this, we will be having a solid understanding of all these concepts, right? And what I was thinking is, let's demonstrate them on AWS cloud, whatever we have learned. So we will be spending good amount of time in spinning some of the virtual machines and creating our own VPC. We won't be dependent on the default one, right? We will be and we are not going to use the wizard also, so that you will be aware of each and every concept, right? Then we will spin up our own internet gateways, security groups, and ACLs, and then we will try to configure them. So the session is going to be interesting because we are doing a lot of things on directly live on AWS. So even I am doing all these things one or twice. Means I was also learning along with you, right? So maybe there are going to be some mistakes when we do things, but be with me. We will be able to resolve all these things. So as a third point in the agenda today, we will be demonstrating all the concepts which we have learned till now. The fourth point of the agenda is, if time permits, this is only if time permits, we will talk about VPC pairing also. What if we create two VPCs? Doesn't matter whether it's on a single region, inside a single region, or across different regions, right? Doesn't matter. But if you want to make a particular virtual machine into a particular VPC, right? Then we need to have a VPC pairing with the other VPC, so that the two virtual machines which belongs to two different VPC can be able to communicate. But we will be covering this if time permits. And so, having said that, this is the kind of agenda for today's session. And let's try to understand what security groups are in cloud. But to understand that security group first, you need to understand the concept of stateless versus stateful, and what exactly is that. So what I'm doing here is I'm taking an example of firewall, right? I have a firewall, and I think if you do not know, firewall is a device where you put your policies with respect to security, right? And I have this firewall here. I have a laptop, and I'm calling this user as A, and I have assigned this laptop a public IP address. Why am I assigning this is a public IP address? Because I do want this laptop should go and talk to internet. Although I can be having a NAT device in the middle, which is going to do the same thing for me. But to make things a little bit simple, just assume for now that this laptop is having this public IP address, this one, right? Very simple. We have firewall in middle, and then we have internet. And on this internet, we have a connected server, which is again having public IP address, which is 5.5.5.5. So all these public address are routable via every service provider, and internet is just nothing but the interconnection of all these service providers, right? So all these, whatever the IP address we are talking about here, 2.2.2.2 or 5.5.5.5 are routable across, right? So no problem with respect to connectivity here. 2.2.2.2 is able to reach to 5.5.5.5, right? And we will be discussing what exactly the packet looks like in terms of IP and TCP with respect to IP address and ports. Although there are many things in a TCP or IP packet or header, but we are not going to discuss that here, right? To understand what exactly firewall is doing here is this host, this laptop wants to make a connection to web server, right? Maybe it is trying to access any website which is hosted on this web server. Yes. So what it do? So you need to understand the theory behind it. If we say that we are going to access the web browser, it means I am initiating a TCP protocol, right, from this, and then basically my source port is going to be anything. My destination port where I need to connect is port 80 because this web server is running on this port 80, right? My source port could be any, destination port is 80, source IP address is going to be 2.2.2, and destination IP address is going to be 5.5.5. So the whole sole intent is that this guy needs to access this thing, right? The server. So the source IP address, let's fill the contents here. The source IP address is going to be 2.2.2.2. Destination is going to be 5.5.5.5. And then source port in the TCP, it is going to be any, and let's say it is 1, 2, 3, 4, 5 for now. And then we will be having destination port, which is a well-known web server port, which is port 80. Okay. So when this packet reaches here, and if I do not have any rules, so consider that these rules are not here for now, the firewall will immediately drop this packet because by default, firewall deny almost everything, right? But if you want to permit in the firewall, right, you need to create some zones, and then you need to create some rules also. So what I have done here is, as a part of one rule, what I'm doing is that the communication from laptop to server, that's why I have shown the direction from laptop to server. I need to permit what? I need to permit a protocol which is known as TCP, Transmission Control Protocol. And believe me, when you make a request to reach a site, the first thing which happens is a TCP three-way handshake, right? So you initiate TCP, then source port in the TCP header is going to be anything. And we have decided that it is going to be 1, 2, 3, 4, 5. Then destination port is port 80, source IP address is 2.2.2, and destination IP address is this, and this is exactly what this packet is. So what I'm doing here is I'm telling firewall that for a specific flow, which is from A to server, you just permit this. It means that if I draw a traffic flow from one direction from A to B, it is going to be permitted like this, right? No problems at all. So, but this flow is only from the direction of A to server, right? But what if the server is also replying? So if you are putting a GET request to the server is going to send you something to you, and that is going to be totally different traffic flow, right? And suppose that traffic flow is, I represent that in the blue. So this blue is actually from the server to A, and that is why I have to another rule which says permit TCP. Source port is going to be 80 this time, guys, right? Source port is going to be 80 because this communication is from server towards laptop A. The destination point, the destination port is going to be 1, 2, 3, 4, 5 because now you are trying to reach A. The source IP address is 5.5.5 and the destination is 2.2.2, right? So I have a separate rule. So it means that the second flow is also permitted by the firewall, right? And why I am explaining all this thing in this much detail is the reason is that when you create these rules, you should be able to understand what is my traffic flow right? From where to where I'm going, it is very, very important. What is the protocol which I want to permit? And that way, basically, you have more stringent rules so that nobody which is not intended to use this service or your VM should not able to access it, right? So please pay close attention here. So now the point is that why do we need to define these two rules? If I have decided that rule 1 is from A to B or A to server, this device should be intelligent enough that if I am going from A to B, it should be allowing me back on its own, so that I do not need to define the second rule, right? Because it is just opposite, or you can say the mirror image, right? Whatever was the source, now the destination in terms of ports and IP address. So why do I need to define this? And that is exactly where statelessness versus statefulness comes into picture. So if this firewall is a stateful device, then there you need to only define this first rule, right? And the second rule means you forget about it, because firewall is intelligent enough that if it is going to permit this yellow traffic in one direction from A to server, the firewall is intelligent enough that yes, if I'm permitting from A to server is going to reply something, and that is why I am going to permit that also. So you do not need to create the second rule here, right? And that is the devices which take care of the second rule, if you define the first one, are called stateful. And believe me, most of the firewalls which we use, like Cisco Adaptive Security Appliance, ASA, or Palo Alto or anything else, they are inherently stateful devices, right? But why stateless then? Because we can create these security policies on the routers also, right? If now this firewall were a router here, then basically we could have created the access list on it, right? And those ACLs are nothing but basically you need to define the traffic on both the direction. Otherwise, the traffic, those ACL or this router is going to be a stateless device, because it is not creating the reverse path. You can debate with me that why do router do? Because router is not a firewall. Router has a specific job. It takes packet from a particular network and send it to the different network. So it didn't mean to be the firewall, right? But yes, it provides some of the capabilities through which we can define our security policies on routers or even on switches also. So I believe this concept is clear: stateless versus stateful. Stateful is anything or any device which is taking care of the second rule when you define the first one, right? And while you define all these rules, you should be comfortable with all these things, that what protocol you are permitting, whether it's a TCP, UDP, or maybe ICMP, what exactly that protocol is. Then you may define source port, destination port, and source address and destination address also, right? If you want to permit anything, means if I have written, suppose if this source wants to go to any IP address, then you can define 0.0.0.0/0, which represent entire IP address range. Okay, so these are some of the basics of what stateless firewall or stateful firewall are. And because we will be utilizing all these things in AWS, right? So in AWS, we have two different security constructs. With the first one is to build your security policies. The first one is security groups, and the second one is ACLs, right? And the concept is going to be same. The ACLs are stateless, and your security groups are stateful. So now consider the same example with respect to security groups in AWS, or basically cloud. We have cloud here, and we have our own VPC, virtual private network, which is part of this subnet or network, right? Which we have in region 1. So what I'm doing here is I have spin up a VM here, And this VM is going to have two IP addresses, as I mentioned yesterday also, the public IP address and private IP address. But you can control the allocation of public IP address, do not worry, and we will be discussing about that. So for now, consider that this VM is having a public IP address, the same address which I have assigned to host, the laptop, and then it is having this private IP address also. Okay. So now this VM wants to go and reach to this server, right? So the first security mapping, or basically first security check, exactly happens at that VM itself, because you attach a security group to VM. And if I say security group, it is a stateful firewall, you can say, right? So you need to define what exactly you want to access, right? So consider there are two types of rule when you define anything on this security group, or basically ACLs. The route or the security rules which are in inbound direction, or the rules which are in outbound direction, right? What is the meaning of inbound direction? If you consider the security group box as you, then whatever is coming towards you comes under the category of inbound, right? And whatever is going out from you comes under the category of outbound. It's very simple, but sometimes it gets confusing, right? So just consider security group box as you, and then basically define inbound and outbound. So you do not want that anything which is going out from this VM is blocked, right? Generally we want everything should be permitted, which is, for example, if this VM wants to initiate a connection at port 80 to this server, we do not want that should be denied. And that's why by default, outbound, we have permit all, right? But it doesn't mean that you cannot control it. You can control it at the VM level. So security groups works at the VM level. In outbound direction, you permit all, because you do not want to deny anything which is going out from this VM. But if you consider somebody which is sitting here, right, with its laptop, and they wants to communicate to this guy, it should be your responsibility to make sure that whether this guy reaches or not. So if it is an authenticated user, if it's an intended user, you want this to be basically your VM, otherwise not. So what you need to do is, suppose you want this user A to SSH this virtual machine over this public IP address. Then what you need to create is basically on inbound direction, you need to create a permit SSH rule. Otherwise, nobody is going to make a connection. Similarly, if you want that another guy, means if host B here wants to, if this host initiates a ping towards this VM, then it should be successful. Then what you need to do is you need to permit ICMP here, right? Because the ping belongs to this protocol. This is really simple. What if another host here, which you spin up here, maybe another VM, wants to communicate to this guy, right? You need to permit that also, because right now outbound direction is not a problem, but the inbound direction is a problem, right? Suppose this VM wants to ping to another VM in the same virtual network, in the same availability zone, in the same network, but still they are initiating a different protocol. In inbound direction, nothing is there. So you need to make sure if this VM, which is part of the same group, right? Same VPC in the same availability zone, if you want to have a communication between them, then again you need to permit whatever the protocol you want to. So security group works at a VM level. I'm not saying that one security group can only attach to a single VM. This security group can be attached to multiple VM. We can have this larger box, and both of the VMs are going to use the same security settings. So in the same security group, you can permit ICMP ping. And if you do that, then basically these two guys can be able to communicate with each other over the ICMP protocol. So first line of defense in cloud on VM is security groups. Okay. I think it's making sense. If it is not, just type your question, and Punish will be taking care of that. Right. I will be stopping after 5 minutes once we finish the ACL, and then I would like to take questions, and then we will go into the demonstration mode. So this concept was really important when you create your own VPC and when you try to communicate to virtual machines. This is the concept. Now the second thing is access control list. There is another layer which this cloud service providers provide us, and that layer is ACLs. And one more thing, guys, I forgot to mention that you can create only permit rules in SGs, right? In security groups, you cannot create any deny rule. Whatever you want to permit, and that is where it becomes interesting, because it is denying everything by default in inbound direction, if you have noticed, right? But whatever you want to permit, you need to have a specific rule for it, and maybe you can define a more general rule like 0.0.0.0, but you cannot specify a deny rule here, because there is nothing called deny in security group. You need to permit whatever you want to, right? So suppose where this is a problem to control at security group level. So suppose somebody is here, a host C, which is an intruder or a hacker, and who doesn't want your web server to be published like it is. Basically, it wants to slow down the performance, and it is sending many SYN requests to you, or many TCP requests to you from a single machine, right? Maybe 1,000 or maybe 10,000 such requests. And when it comes, you need to process it. And when you process all these requests, and all these requests are dummy requests, means it is going to send you TCP SYN, but not SYN. Sorry, the next packet, right? So basically, the problem is your server needs to process it, and exactly that is where these denial of service attacks comes into picture, because this intruder is sending you something which you need to process, but which is of no use, right? But your computing powers goes into it. So suppose the IP address of this intruder is x.x.x.x. So at security group level, you cannot create an inbound rule which says that you need to deny this x.x.x.x. You cannot control it from the security group level. And that is where you need another security construct to build your security policy, which is access control list, right? Which is very much similar to what you define here at Cisco routers, right? So that is basically, it works at the main router level here. And again, this ACLs, you can define rule inbound or in outbound direction. The rules structure is going to be same. Specify the protocol, then specify the ports, and then basically you need to specify the source IP or destination IP addresses. This can be done in inbound and outbound direction. The action could be permit or denied. So it means that if you want to control that user C, right, you do not want to send basically even any packet from that user to this VM, and that's why basically you deny this at one level up by applying this rule, right? Here, basically at ACL. So there are two different security constructs on which you can build your security policies in cloud. First one is security group, which is stateful, and the second one is the ACLs, which are stateless. Okay. So having said that, Punish, can you hear me?
Yeah.
Okay. So can you read some questions if there are any, or we can continue, whatever you say.
I think it's more related to the basics of ACL and stateful and stateless.
Mm-hmm.
So that's one from Vinny. That's any advantage of any advantage of stateless or stateful over the other.
Yeah, stateless, basically
What is it?
you don't need to create that rule number to the reverse path, right?
Yes.
Because the device is intelligent enough to know that if you are permitting something which is going out, you need to permit when it goes inside. No advantage, but different use case, you can say. But yes, statefulness is basically where the traffic is going through it in both direction, and you do not want to create the reverse rule. Anything else, Manish?
Yeah, we can take one more. Why do we need both of them, security group and ACL?
Yeah, so basically, although both are doing almost the same thing, but as I mentioned, that we did not specify the deny rules, right? Because we do not want to bombard this VM with all this processing at the SG level. So basically, they have divided the security policy into two parts. One is more closer to VM, and the second is more closer to basically whoever is trying to access your network. Yes, but there is a different use case for it. Can we move, Punish?
Yeah, I think, yeah, we can.
Okay. So guys, just post your questions as and when, and we will be taking some time to take them in the middle of the session also. Okay. So let's go and discuss the third topic of today, which is again very interesting. And this is the demonstration of concepts like VPC, Internet Gateway, and security group, ACL, whatnot. So, but you need to understand, you need to make your make a model, visual model, that what exactly we are trying to achieve, because otherwise making it is very easy to get confused, right? So just try to make a mental model or visual of what we are trying to do here. So first of all, we will be creating our own VPC. We run an organization, say XYZ, right? And we want to create a virtual private cloud of this organization into a cloud service provider, which we call as AWS, right? So whatever the activities we are going to do in Amazon Web Service. But it doesn't mean that you cannot do the same thing in Azure, right? You are free. Basically, Azure also provides the free tier service, which you can always make sure you can use for your labs. GCP also does that, but we are using AWS, right? So here, what we are going to do is we are going to create our own VPC, and my organization name is XYZ here, right? Once I create that VPC, and if I want that VPC should go out and reach to internet, then basically I need to attach a internet gateway to it. So second step is we will be attaching an internet gateway to it so that we can go out from this VPC and reach to internet, right? But now, if I want to create different virtual machines in different availability zone, I need to subdivide this network, right? And for that, basically, we use CIDR, which is classless interdomain routing, which we discussed yesterday also, that we have this complete range, and now we are dividing this range to multiple subnets. For example, suppose I run these two virtual machine VM1, virtual machine VM2 in a single availability zone, maybe it's a Mumbai region, and then maybe inside the Mumbai region, this is a single availability zone where I want to spin these two virtual machines, and then I need to assign an IP subnet range for it, and that's why I have chosen this range, 10.10.10.0. Maybe for a different availability zone, I can choose 10.10.20.0/24. Okay. So it means that we need to define this subnet also, and we need to attach this subnet to availability zone. Correct? So the third step, we are going to create subnet. Right now, basically, we will be creating only one subnet, but maybe in tomorrow's demonstration, I will show you that we can create these VMs across availability zones and across subnets, and then basically we will be able to communicate between them. Or maybe you can do this exercise on your own, but for now, we will be creating one subnet inside this VPC, which is a part of this range, right? Classless and we will be using CIDR, which is going to save us a lot of IP address, right? So we also call, guys, this as a super netting, right? The CIDR thing. If you're not clear, just go and watch the video on my website, right? So SharePoint website, which is available to all of you inside Cisco. Here, the fourth step is we need to make sure that in the security group, we enable SSH and ping. Why SSH? Because once it is done, once I spin up these virtual machines, we will be getting IP addresses, right? And these IP addresses should be reachable from outside. Otherwise, I won't be able to reach this virtual machine. So that's why what I'm going to do is I will be enabling SSH and ping, right? And one more thing, while creating this subnet, I need to make sure that these VMs should get an IP address, public IP address range, along with private IP address, so that anybody can talk to them. And that is how, for example, I will be creating everything in this AWS, right? But at the end of the day, I am sitting on internet, right, with my laptop. And how I will be accessing this VM? I will be accessing this VM over the internet, over this traffic path, right? Over this traffic path, like this. It means that what protocol I'm going to use? I'm going to use SSH, right? While accessing this virtual machine. And if I'm using SSH, I need to permit this SSH also here, right? The second thing is, if I want to make a communication between this VM1 and VM2, I need to make sure that ping across them is working fine. There is no problem with respect to reachability. But yes, as I mentioned, because first line of defense is security group, we need to permit ping also, otherwise this virtual machine is not going to ping this one, right? Once we attach this internet gateway to this VPC, it means that we need to tweak this routing table also, right? All that should be done on its own. But what we are going to do is we are going to create one static route which says that anything inside this VPC, if they want to go outside, then they need to go outside via this internet gateway. Okay. There are 5 steps, but maybe you can take a screenshot of this screen right now. So whenever we start doing all these things live on AWS, you have a clear visual that what we are actually doing. Okay. So having said that, let's begin and try to do all this step on Amazon Web Services. Okay. So let me open Management Console here. So when you go, you will be seeing all these things like this, that no instance is running, nothing, right? And I forgot to mention one thing. If you do not do all these things, right, which I mentioned here, still the things will work in the default mode, because already there is a default VPC, there are default subnets, everything is there, right? But we need to create our own network, right? We don't want to be dependent on default, and this is going to be the thing which come across you when you're trying to deploy your own network according to your own needs. That is where basically you do not want to use all the defaults, right? So defaults will always be there, and we will be seeing them also. We will be seeing them also, but let's have a look at this first. So if you go to VPC here, and this is the VPC service offered by Amazon. Punish, can you see my Chrome, my browser?
Yes.
Yeah, okay. So first of all, if you want, you can select a Mumbai region from here. The region selection is important. Then if you can see that we already have one VPC here. This is the VPC. This is created by Amazon on its own. And they have already assigned a IPv4 CIDR also. Classless inter-domain routing, right? IPv4, this one. So what we want to do is, as a part of our own exercise, we are not going to be dependent on this, right? In fact, if you see internet gateways here, it is already there. if you see route table, the global route table is already there, but this is all with respect to the default thing, right? What we need to do is we need to create our own things. Okay. If you consider here the security groups also, they have some security groups already defined, right? And if you see one of them, then you can see that basically they are permitting like which version of protocol, SSH, TCP, or whatever, right? So guys, believe me, if you create an account here, it is going to be really beneficial for you if you are planning to learn anything with respect to networking in Amazon or anything else. Okay, so let's go towards VPC here. But you can see the mouse movement. That is fine for me. That if you go to the VPC here, one is by default system has created. Now we'll go here and create our own VPC, right? So my company name was XYZ, and this is going to be my first VPC, right? And I need to decide what is the subnet range for this one. So I am going to put the subnet range here, which was 10.10.0.0/24. Okay. And now just leave other things on its own. That is fine. So what I have done here is I have simply created a VPC with this name, and I have decided to use this CIDR block for this. Very simple. And let's create VPC. Okay. So here is the VPC they have created for me, and the name they have come with the VPC, this one, right? If I go again to your VPC, I could see now 2, and this is the one which we have created. It's very simple, right? So what exercise we have done till now, if I go and look into here, so I just created this box here inside the global AWS network, this block, right? And I named it this one. And then basically what I did is I created a subnet to begin with for this complete VPC. And then I will be subnetting it, means create smaller subnets out of it. Okay, so this step is done. Now the second step was to attach internet gateway. So let's go again here, go to internet gateways here. This is the one which is already there. So we will create another internet gateway here. We will name it as XYZ internet gateway, and that is it. So basically, you might be seeing that the creation of all these constructs is very simple here. And this is the services offered by Amazon. These are part of the services offered by Amazon, right? So we have this gateway configured, but now this gateway is somewhere else, right? System doesn't know, AWS doesn't know for which purpose you have created this gateway, right? So what we are doing here is, we are going into action and then attach it to VPC. If you don't do that, then basically AWS doesn't know where this gateway is to where I need to connect, right? So you need to do it manually. What we are doing here is we have created the gateway. Now we are going into this action attached to VPC. And which VPC you want to select? This is the one which I have created, right? And then we are going to attach internet gateway. This is good, right? So you have your VPC, this one, and this VPC is connected to the gateway. What is the gateway? Here is the gateway, okay? And it says that it is attached to this VPC. We are good till this point. Now, the third point is, if we go to the route table, we will be seeing now 2 route tables here, right? This one is the main route table. This one is the route table which is created by me. So again, with respect to picture, I think you will be getting it, but for everybody's understanding, what we have done is we have created this internet gateway here, and then we have attached this to this one. It means that this link, what we have done, right? And now we are tweaking something into this route table, because you know that if we want to make sure that this guy has the internet reachability, I need to make sure that this route is there, the default route, right? So what we are going to do is we are tweaking the route table. Which route table? The main route table of this VPC, right? And there must be two route tables, route table 1, route table 2. Route table 1 is for the default VPC, which Amazon created for you. And now I have created another route table, which is having this IP address on its own. And we will be introducing the default gateway here, right? Okay, so let's go there once again here. And let's select this route table, which is my route table, if you can see here. Because this is the route table created for my VPC on its own. If you go here, you can see that this route is already there, 10.10.0, which is the overall subnet range which we were using. And that is what I said, right? By default, you will be having this route, 10.10.10.0, 16 via local. And exactly, you can see it here. Destination is this one, target is local. So if there is any communication between this set of group, the AWS is intelligent enough to know that this is part of my own VPC and I need to switch the packet locally. Okay. But if you need to add this route table towards internet, then we need to edit this route. And let's add one route here. And I want to add route which is going to all the hosts, which is 0.0.0.0/0, and the target is going to be your internet gateway, right? Where is the internet gateway? Here is the internet gateway. And what internet gateway you have specified there? This is the one, right? Very simple. And then you do the save changes. This is very simple. Now your main route table of your XYZ VPC of your company is having two necessary routes. This is perfect. Okay. Now we need to define the subnets. We have defined the network. We need to define the subnet. What these subnets already are? These are already the subnets for the default network, which AWS has created, right? So we need to create one subnet here, but to which VPC I need to attach this subnet to? Of course, the VPC which I have created. Now it is asking few more things. What is the name of this subnet? XYZ company, say first subnet. And what is the availability zone? Okay, I will choose the first availability zone which is available to me. And then I need to define the IP address range, right? So I am going to use the first 10.10.10.0/24 as part of this CIDR block. And that is it. Create subnet. Okay. Subnet 1. Yep, Nish, go ahead.
The third octet should be 0, correct? I mean, or probably we can do like.
Okay, the problem is basically I've designed the VPC. It should be /16 actually.
Yes, correct.
That I made a mistake, right? Okay, so let's then divide it into two parts. That's perfectly fine. So basically we are just going to use some subnetting skills, guys. And if you don't know that, because the mistake which I've done here is it should be 10.10.0.0/16 so that I can carve out /24, but now it is /24. I need to carve out some range out of it, right? And what I am doing here is I am doing this 10.10.0.0/25. So it should work now, right? So starting, or basically you can give 26 also. So, but it should be greater than that. So for this, starting 128 IP addresses will be assigned to any host inside this. So create subnet. That is fine. This is good. So that was your subnet here. And we are good. Okay. Okay, so what we have done till now is we are good with respect to all these steps. We have created our own VPC. We have done this, but we did forget one thing, that out of this subnet, basically I want to make sure that every host in this subnet is going to get the public IP address, right? So what I need to do that for that is we need to just go to this act here and then edit the subnet setting, and I make sure that I enable this. Right? What I have enabled, enable auto assign public IP address. So if you do not do this, only the private IP address is going to be assigned to you, and you won't be able to reach at the first place to this guy, right? So save it. Now we are good to go to spin up the VMs, right? We are done with all these steps, right? This one, this one, this one, and yes, this is still remaining. We will be doing it once when we create that instance, and then default route is also there. So this is good. Let's go here and let's go to EC2, which is elastic compute, which is used to run your virtual machines on cloud. Let's go here. This is good. Let's create. Let's launch an instance. Launch instance. Okay. And guys, when you do this, just try to make sure that you select a virtual machine which is free tier eligible here, right? As I mentioned yesterday. So what we are going to do is this: choose instance type, configure instance. Now here are the things which you need to take care. Now we are not part of the default VPC. We will be part of our own VPC, and here I have defined only one subnet, which is good. And then we go to add storage. That's fine. Add tags. We do not want to do that. And now here is the important thing, which you are saying configure security groups. So SSH is already available here, right? I want to add one more rule, which says enable ICMP for, right? And then port range is nothing. Custom from anywhere I want. That's okay. Okay. So this is good. Review and launch. So let's see. Let's launch this. And while doing so, I need to get my public private key pair and then launch instance. Okay. So we have this instance running, right? And we can always say that this is instance 1. Okay, just wait a minute, guys. Instance 1, save. Okay, so if you consider this, if I refresh it once again, it's still showing me it's in pending state, but it should be running soon. Yeah, it is running. If I go and check all the things, so guys, you can see that it is having this public IP address, it is having the private IP address, right? And then with respect to networking, if you go, then we have all these parameters. And security groups, if you can see that inbound role for inbound rules, we have all these things. For outbound, we have which we have defined, right? This is for IPv6, which I'm not interested now, but these two things are for you. So we are good with respect to this. So if we connect this and at this IP address, right, and which I'll show you that how to connect. So if you go here, session manager, I am doing a new session. Okay, so session name is this one, and then we have host name, this one, username Ubuntu, and public key I have specified. Okay, let's connect, accept and save. Punish, you can see this application also, a secure CRT, correct?
Yes.
Okay, let me bring it slightly bigger. So if you see this, then if I do config here, you can see the IP address, which is here. And then I can go and reach out to internet also, which is cool, right? So if you consider time, then basically I don't think that we will be able to make another VM and then start communicating with it. So we'll do this demonstration tomorrow, right? And then for now, I'm just going to repeat whatever we have done till now. We have created this VPC, we have created this internet gateway, whatever is required. But the mistake which we have done is, instead of doing 10.10.0.0/16, we are carving out subnets from this, right? 10.10.0.0/24. So we have done all the steps. What we were able to make is, we were able to make this path also. Means this guy, the VM1, was able to reach to internet, right? Somewhere here to www.google.com. Okay. So as I mentioned, that if time permits, we are going to discuss about VPC pairing. But as you can see, time is not permitting us. So we will consider this topic tomorrow. And now let's take questions. Punish, do we have any questions?
Yep. So this one, can we assign a static IP to a VM instead of dynamically assign IP from subnet pool?
Yes, we can do. We can do. And this is the subnet property actually. This is the subnet property through which we can do this. Yes, Punish, anything else?
1 second. One TCP connection has been established. The server assigns a random port to be used for actual data.
Yeah.
Is it okay to just add permit rule in ACL, permit port 80 alone?
Permit port 80 alone is fine, because if you are communicating, see from which perspective or from which direction you are saying. For example, if I am a laptop, right, and I am trying to go to port 80 or web server, then I know what is going to be my destination port, right, which is port 80. But this is the responsibility of system or operating system to decide on what exactly it is going to use as a source port, which is quite random when you connect to a web server or web. So you cannot define exactly through which point you are going to make a connection. But if you consider the server side, right, server is only listening on port 80, and it doesn't know from which source port the packet is going to come. So anyhow, when you define a flow from source to destination, the source is going to be anything, and destination is fixed because you know the destination. Yes, please, Punish. Any other question?
Yeah. So I think there are a few questions probably that will be covered tomorrow in the next session. So, but still, let me. So one is from Sandeep. That's regarding security group. If we want to permit VM1 to VM2, port 555, let's say. If you permit this on SG, all the internet users will be allowed to send packets.
So that is why there is a second level of control which you can do, which we haven't explained. So there is a second level of control. If you can see here, I haven't mentioned here, we have ACLs also, right? Irrespective of that fact, whatever you are defining here, it is just between your VMs or anything which wants to meet to which want to reach to these VMs from outside. And that is why we have second. So you answered the pretty good question which other people have in their mind. Yeah, Punish?
So that's okay. Can you provide QoS to participate? Sorry. Can you provide QoS to particular VM in the VPC?
Sorry, I do not know about it, but it's a really good question. I'll go and check. Maybe tomorrow I will be providing answer for that. But yes, I do not know about it. And believe me, I'm learning with you guys, so these questions help, because these questions challenges me to go back and learn few things more. And thank you so much for this question. Yes, Punish?
Okay, that's one. we can take it. So in the lab, when we define security group for ICMP, did we choose direction as in or out or in? I think we
Yeah. So basically, in security group, in outbound direction, everything is allowed because you do not want to stop the communication which is going out from you, right? So, but the inbound direction rule is interesting there. Yeah.
As we can take, it's yes, Varna, from this IP config in VM was not showing public IP. Why?
IP config in yeah. So that is the construct which is it is not the case that we cannot see it. If you can do who am I, or sorry, if you for example if you run a web browser in it and you show what is my public IP address, it is going to showcase you. But yes, on the NIC itself, there is a private IP address. Yeah.
Yep. I think that's overall we have.
Okay. So we are good this way, I believe.